Well, kids, here we are, Tuesday, March 24th, fourth day of digital learning. Hopefully, things are going okay for you so far. It's been a little bit different for me. Lots of emails and messages, and lots more time on the computer than I'm used to. I'm guessing you're experiencing some similar things, but hopefully, it's becoming more manageable and a little bit more routine for you. And things will get easier the more that we continue. So, today I want to start by talking about what should be already completed. And you can see on my screen here that there are really four things that should have been done or turned into me. I want you to look at these icons, like right here. This icon, it looks like a clipboard. Wherever you see a clipboard, those are things that need to be, there's something for you to do, whether it's take an online quiz, whether it's to turn something in. So there have been four of those since we've started this. The first thing was the layers of the atmosphere quiz. Almost all of you have that turned in. There are a few of you that don't have that turned in yet. The second thing was the ozone layer and atmospheric pressure quiz. Again, it's like 4 or 5 questions, pretty easy, multiple choice. This is not out of your head. You are supposed to be hopefully taking this quiz after you watch the lesson and have gone through the book with me in the lesson. So by easy, I mean we're definitely going over the material. You need to use that material to help you with the quizzes. Today, there were a couple of things. One was the layers of the atmosphere worksheet turn-in, and that was this page in the packet. Now, quite a few of you have turned that in. There are some that I have not seen yet. Ideally, you upload it through Google Classroom. There have been a few people that haven't been able to make that work. They've just taken a screenshot of it, emailed it to me. I can make that work too. I would prefer if you got it to me through Google Classroom, but if we can't, we can't. So I will take it either way that you get it to me. And then the final thing that I have for you for the day was the radiation conduction and convection quiz, which again, you're supposed to take that after you watch my video lesson. 4 questions today, I believe, all multiple choice. So after the lessons, really I should see, maybe by noontime or early afternoon, I'd love to see all of those quizzes getting completed, because that means you've watched the lesson and you've taken the quiz, and hopefully you've done pretty well with that. I am going to get that stuff in Skyward starting tomorrow. So if you're missing anything out of here, that's going to start to impact your grade a little bit. And I think Thursday is the end of the quarter, so we only have until then to continue to get grades. All right, so that's enough about the past. Now into the future, or the present. I'm looking back in your textbook here. This is where we left off, radiation, conduction, convection. I'm going to finish with a little bit of that. But I want to just touch base on the last couple of things that are in this section. The first of those things is the water cycle, and that's something that I know that you've been taught several times in your educational career. We're not really going to focus on it all that much right now, because again, I assume that you know what it is. You can read through the section if you need to. What I like about the picture here is that it shows all of the parts of the water cycle that are important to us. We have surface water, which would be the ocean, the lakes, the rivers. Heat from the sun can cause evaporation to occur, which changes that liquid to a gas. The gas rises in the air. You should know what happens to temperature. The higher you go up, the cooler it gets. So that cool air causes the water vapor to condense and make water droplets. That's what clouds are made out of. The clouds are not gas. They are liquid water droplets or ice crystals, depending upon how high they are. Eventually, that moisture comes back to the earth in the form of precipitation. We're going to learn about the types of precipitation: rain, sleet, snow, hail. And eventually, it falls back to the surface, where we get runoff and back into the surface water areas. There is a component of this underground. And that'll be something that we take a look at a little bit later on in the school year with groundwater. So just a quick review of the water cycle. All of it together in your book, we call it the hydrosphere, all right? Condensation, evaporation, precipitation, heating and cooling of water creates this cycle, all right? So moving on to the last thing in the chapter is just kind of a heads up that, hey, our atmosphere is unique. And because we are adapted to be able to survive in this atmosphere, it allows us to thrive here. And what we really have to be mindful of is that atmospheres on other planets are quite different. As it says here in Mars, there's very little atmosphere. It's very cold in the shadow. It's very hot in sunlight on Mars. Venus has got kind of an opposite problem in that its atmosphere is too thick. It's filled with carbon dioxide, and so any heat that penetrates the atmosphere is really trapped. And Venus is extremely hot, 470 degrees Celsius, almost 800 degrees. So life can't exist in the way that we know it on those two places because their atmospheres wouldn't allow for it. Our atmosphere, it works for us. And really, it's probably the other way around. We are adapted to the current atmosphere. All right? And that rounds out section 2. And I want to go back to the assignment that's going to be due Wednesday. I gave you a heads up about this yesterday. The assignment is right here. It is this page called Transfer of Heat, Radiation, Conduction, and Convection. And what you're going to need to do for those three, I mentioned to you yesterday, draw me pictures, draw examples of radiation, an example of conduction, an example of convection. And I also have you label different parts of that drawing. Here we can see I have you label the heat source, the direction of heat transfer, where it comes from and where it goes. Remember, heat always goes from the hot thing to the cooler thing. And then describe in words what's taking place in the diagram. So what I thought I would do is I would draw you an example of something that you might use for this assignment. So as you can see, I now have a lovely whiteboard. So I'm going to do my best to draw large enough for you to be able to see what the heck is going on here. All right, so the example that I'm going to do is radiation. And keep in mind, you can't steal my examples. You got to come up with your own examples. So I'm going to start with kind of a janky looking campfire type scenario in here. And I'm going to show that it's a campfire. Gosh, I wish that was bigger. I can kind of see it on there. It's not great. I'm going to show that it's a campfire because it's going to have these flames coming out of it. Now it's starting to look like a fire. You can see my 4 college art classes are totally paying off at this point, right? I'm going to add, I'm going to add a stump that someone is sitting on around the campfire. And now I'm going to draw a world famous, this could be tricky, stick person sitting next to the campfire. And of course, we know that stick people typically only have 3 fingers, which is why I have 3 fingers there. Radiation. How does this picture describe radiation? Well, one of the things that I have to label for that assignment that's on the screen right there is the heat source. And obviously, you can see that the flames in this example would be the heat source. Secondly, I need to show, let's see, the direction of the heat transfer. So the heat is going from what to what? Well, in this case, and I'm going to do this in green, the heat is being transferred from the flames to the hand. So heat from the flame to the hand. By the way, I also just did the hard part, the last direction that says describe in words what is taking place in the diagram, right? Heat is from the flame to the hand. Ideally, I would have put heat is transferred from the flame to the hand. And finally, actually, I'm going to add a couple more words to that. Heat from the flame to the hand in rays and waves. That is the full description of what's happening there. Heat is transferred from the flame to the hand in rays and waves. All right. So looking at the directions, did I do everything I needed to in the directions? Picture illustrates the transfer of heat. Label where the heat source is. Direction of the heat transfer. And describe in words what's taking place. Boom. That's it. That is my picture for radiation. Now keep in mind, you can't steal mine. You got to come up with your own. I will encourage you to look back at this page, radiation, conduction, convection. You can look back at my last video and it will help describe those three things as well. And you may look up here at these pictures. There are some examples there as well. You can use these. They're not labeled. You're going to have to label them yourself. All right. So that's it. That's the lesson for today. Review of radiation, conduction, convection, the water cycle, and why the Earth's atmosphere is so unique and special for us. So just a reminder, Wednesday, this drawing page is going to be due. Here's a third of it. It's not a whole ton. All right. You can handle this in a very short period of time. So that's going to be due Wednesday. What's due ideally after you watch this video is the very short quiz I'll have. Maybe 3 or 4 questions today is all. So watch the video, take the quiz, and you should be, maybe do 1 or 2 of your drawings today, and then the other 1 or 2 tomorrow, and you should be in good shape. All right. So with that said, remember you can reach me by email, you can reach me by Google Hangouts, Google Meet, any of those ways, and I am glad to help you. So with that, I hope you have a wonderful day, and I will talk to you tomorrow.